continue with the lesson. In this case, we are talking about how to determine the volume for different geometrical shape. And the two shape that we are talking now is the spoil bank and spoil bank and spoil pile. So in terms of spoil bank, what do we call that, and when we apply? Normally we apply in the horizontal construction, building bridge, building the road. That's something the length is very long compared to the width. So in this case, we have the L much greater than the width. So let's talk about the triangle spoil bank. For example, if we have a triangle shape and it keep continue, we put the soil in and it forever here continue. So we have the here a cross section of the bank and call that height H, and the base B is the base, and this is a triangular cross section. Triangular cross section. And the L is basically the length of the bank. L. And as you can see, there is a R, which we call it angle of repose, and that you learn in Geotech 1. So that let me define that here. This angle, everyone recall what is the angle of repose? Let me put here that is angle of repose. So what is the angle of repose? Basically, it will be the critical angle of repose of a material. In this case, the soil is the steepest angle of descent that the material can be piled without slumping. So that we call it angle of repose. I will show you different material with different angle of repose in a minute, but just let them get some equation here first. So with that in mind, for this one, with the triangular cross section spoil bank, what is the volume look like? So as you can see, very natural, the equation is volume. For this, V equal to section area, so the cross section area, time the length. And the length. And then we have the B, the base. How can we determine the base? B equal to, with the V, for example, if you know the volume, I want to know what is the width of the side so that I can dump this type of material. So basically the base, determine the base. So it will be equal to 4V, and that in your chapter 2 times L, which is the length. For example, if you put along the road, so the length of the road, tangent of the angle of repose, and root square. So that is the base. What is the height of this pile? So the height equal to the base times tangent of repose divided by 2. And of course that is purely geometrical properties of this shape. But in the real life, when you know the volume and I know, okay, how much the site needs, you need to determine the B, right? How high can I have that in here, or with the high limit for certain areas, I need to reduce the height, and then associate, we have to reduce the B. So that the relationship between the volume, the base, and the height of the spoil bank with the triangular cross section. The second type of volume normally we do for the building, which we call it vertical construction. It is spoil pile. And in this case, we apply for the fixed location and conical shape. Fixed location, conical shape, conic. Okay, so let me draw that one concept. So it will be here, and the base, it will be a circle. It will be circle, and we have the diameter, and we have the height. So that's the same height, and we have the diameter D. And of course, for that we also know the here this angle, that is angle of repose. Angle of repose R. So from that we can have the equation to determine the volume, what is the diameter, so that we know what is the size should have to occupy such volume of material. So they have relationship. So in this case, as you can see, the volume equal to, for conical shape, as you can see, it will be 1/3 the Pauli geometry, the base area, and time the height. And to determine the base, in this case the base is the diameter. In this case, diameter. So we have D equal with the transformation of this equation. So we have 4764 times the V divided by tangent of R 1/3. So base area, if you see that for the circle, it will be pi r square, right? Or pi d square over 4, you plug in there, and the height, you can find relationship between D, angle of repose R, and D, so that you can find out D with that transformation from the volume. And then we can determine the height. Similarly, it equal to D over 2 tangent of R, basically the relationship in the trigonometry in there. So that you can have the equation for both scenarios. Spoil bank normally apply for horizontal construction. Spoil pile apply for a fixed location, typically vertical construction, building, build a building, etc. So with that, we can quickly apply for problem 2 for spoil bank and spoil pile. First, find the base width and the height of a triangular spoil bank containing 100 BCY, bank cubic yard. If the pile length is 30 feet, spoil angles of repose, so angle of repose is 35 degrees, and its swell is 30%. Swell is 30%. So as you can see, the bank condition is 100 BCY, 100 BCY. So we have to transform that to the loose cubic yard, because when you stock the soil at this pile, it already disturbed the material. So we need to find out the loose cubic yard, and that we apply to the previous lesson. The previous material we talked in this lesson. Basically, apply the soil volume change characteristic. We need to find out the volume in loose cubic yard first. So let's do that problem here. We have A. The volume given 100 BCY. We have to change that to the loose cubic yard. How to determine? It equal to 100 times the 1 plus square percent, right? Square percent. And with that, we can plug in. It equal to 100 times 1 plus 0.3, and we may change that to it is BCY to loose LCY, so we have that is 130 LCY. And because the question here is feet, so we have to be unit, the same unit, so you change that is cubic feet. And if you recall, you time 27, right? So it equal to 130 times 27, so you will get 3,510 cubic feet, loose cubic feet. And then you just apply the equation for the bank here, B and H here, so that you can find out the what the question asks. So B, from that I can have B equal to 4 times the volume, 3,510, divided by the length L times tangent of repose, square root. Tangent 35 degree, 1 root, and same unit you can see there, so it will be 25. So keep that in mind. We have to change the unit in there. 0.9 linear feet. Okay. And then we have H, the height of this bank. It equal to, you see, B tangent of R over 2. So you have what it be, 25.9 tangent of 35 degree over 2, so it will be 9.1 linear feet. So that is the height. And then similarly we do for number B, and now we can do a little bit faster here. Find the base diameter and height of a conical spoil pile that will contain 100 bank cubic yard of excavation with the angle proposed 25 degrees. And of course we do the same and square with 15%. So we can do exactly the same, but the square with 15%. So we can have 100 BCY, and I can do a little bit quicker now. Time 1 plus square percent, 15, time the unit change to 27, so that for cubic feet, so it will be 3105 loose cubic feet. And we apply equation, in this case the base diameter, so you can find out D equal to 764 times volume 3105. That equation we have here, everyone see that, right? So we can have that one, and over tangent of 25 degree, 1/3. So you have it 37.1 linear feet. And similarly the height, it equal to D over 2 tangent R, so we can apply here. D already find out, 37.1 over 2 tangent of 25 degree. It will be 8.6 feet. And with that, we finished here, and just go to the next slide. You can see for the angle of repose for different type of soil. So if the problem don't give you the angle of repose, for example, in the example here, they give you 35 degrees, 25 degrees. Then if they give you the type of material, for example, clay, you can be able to estimate that it's 35 degrees. If it's common earth dry, 32 degrees. Common earth moist, it means wet, 37 degrees, etc.